Hi, welcome my Algebra 1 loving friends. We're jumping into Algebra Lesson 38. I'm so sorry, this was Lesson 37 we did from a previous lesson. So we're actually jumping in today to Algebra Lesson 38. Isn't that so exciting? We've worked so hard. We've got 37 lessons under our belt, so to say. And we're plugging away in Saxon. And I am truly thankful that Saxon is so heavy on review. So those lessons we've had before, we're going to see again, aren't we, friends? All right, so we're looking at ratio problems. Now, ratios can be a little bit intimidating. But you know, a ratio is just a comparison of two numbers. You can write it just like you can write a fraction. The only difference I want to point out is fractions, if maybe we have the numerator is over 1, then we change it to a whole number. You can never do that with a ratio because that would take away the whole purpose of a ratio, is to compare two numbers. So if I have 4 boys to every 1 girl, you can't say, well, now I have 4, because you're comparing boys and girls. So if you take away one of those numbers, you can reduce them just like fractions, but you cannot turn it into a whole number. So your book shows you how to write those ratios. And then it talks about two ratios set equivalent to each other we call a proportion. Now what's important to know about proportions is their cross products are always equivalent. So that makes for nice problem solving there, doesn't it? So the cross products, and we call those the means and the extremes. And as long as we set up a ratio in the proper format, then they're easy to solve. So I've had a lot of students be overwhelmed with how to set those up. And for me, a big help in setting up ratios is making sure that you set it up in an organized fashion. So sometimes I'll just put a little label or something just to remind myself how to do that. So your book on page 153 and 154 goes through some examples, and they show you how to set those up. And they also show you how they've even set them up using initials, just so that they make sure that they set it up properly. So they show you different ways, because I don't want you to be at home and say, well, I'm not sure. What if someone else set it up differently? Remember that as long as your cross products are equivalent, then your answer will be correct. All right, so let's do some examples on page 154, shall we? So we're jumping into practice A. And it says the ratio of neophytes to masters. And I was talking to one of my classes about some of the fun terms that Saxon uses in its story problems. So we'll just call them N's to M's, right? At the tryout was 7-2. And what's important is to remember that order matters in ratios. So if it said the ratio of neophytes to masters, so it's N to M, and then it said 7-2. So that's the way that it should look, just so that we know the 7 goes with the N, the 2 goes with the M. All right, now we won't keep those. Those aren't variables. It's just kind of for us to remember which one's which. All right, you can even do it as a subscript. That way you know what your order is. If there were 714 neophytes, how many masters were there? So do you see it said 712 neophytes. So you have to decide, where do I put that? Well, I've already put N on top here. So if I'm seeing that my ratio is 7-2, and I remember this is N and this is M, I'm going to set it equivalent, and I'm going to put 714 here because it's the N, and I'm looking for the M. That's my question mark. Or I can make it a variable. That's my X, right? That's what I'm solving for. I don't know. So it says the ratio was 7-2, and then 714 neophytes. So I knew that that goes here and not here. So that's why it's important. Now remember, the cross products equal each other. 7 times X is 7X equals 2 times 714. Now you can grab your calculators or you can multiply it out with me. 2 times 4 is 8. 2 times 1 is 2. 2 times 7 is 14. So I've got 1,428. But notice I've got 7x. I've got to get my variable by itself. Inverse operation is divide both sides by 7. 7 goes into 14 2 times, and then 7 goes into 2 none. 7 goes into 28 4 times. So x equals 204. Now let's take a moment and just ask ourselves, is that a reasonable solution? Because remember, math is always fair, it's always logical, and it always is practical, right? So if neophytes was larger than masters, 714, is that larger than 204? Yes, my answer is reasonable. In fact, 7 is more than double of 2. It's more than triple. So more than triple of this is 714. So our answer is reasonable. And that's one thing to always do. When you solve for a problem, always ask yourself, is that reasonable? Because a lot of times that will help you catch careless errors. Or maybe if you set it up wrong, if you maybe weren't paying attention to your labels and put 714 down here, that would give you a much different answer. So that's why it's important. All right, that's letter A, so let's mark that. And then we just have one more practice, so let's go ahead and do that together. The crowd in Belgrade Town Square was made up of Croats and Serbs in the ratio of 3 to 5. So the ratio was 3 to 5. Now, let's remember which one's which by going back, and it gave us that order. Made up of Croats, C, and Serbs in the ratio of 5 to 9. If there were 18,000 Serbs, well, Serbs is here, so I'm going to have to put 18,000 here. Serbs, right? How many Croats were there? So I don't know. I'm going to go ahead and put C for my variable. So I'm just going to do the cross products. 5 times C is 5C equals 3 times 18,000. That's a big one, isn't it? So 5C equals, I've got 3 zeros. Then I've got 3 times 8 is 24, carry my 2. 3 times 1 is 3, plus 2 more is 5. So 5C equals 54,000. Now I'm going to have to divide by 5. So C equals, 5 goes into 5 one time. 5 won't go into 4, so I'll bring my 4 over. And 5 goes into 48 times, and then 0, 0. So yes, my answer is 10,080. Now, let's ask ourselves again the same question. Is that reasonable? Well, 3 is less than 5. 10,000 is less than 18. So it seems very reasonable, doesn't it? All right. So that is our 2 practice, and that's setting up ratios. So I hope that helps you feel a little bit more confident in setting those up. Now, lesson 39, our last lesson this week in Algebra 1. Lesson 39 points, it sounds a little bit intimidating. In fact, we talked about this in class, but it was right as we were heading out. So I hope that the sound of what we're learning doesn't sound too intimidating. You know, sometimes we can hear terminology and we might even feel for a moment that that's something that must surely be something difficult, right? So we're looking at the trichotomy axiom. Now, if you say that in a British voice, it makes you sound more dignified, doesn't it? The trichotomy axiom, right? It just sounds more dignified. But when we hear that, we think, oh no, what if we have to have like a doctorate to talk about that? Well, friends, it's actually a very easy concept. It's just saying that when you compare things, there's only 3 possible choices. So like say I were comparing X and 5. Well, there's 3 possible options. So let's talk about those 3 possible options. X could be less than 5, X could be equal to 5, or X could be greater than 5. Friends, that's the trichotomy axiom. That just means that there are 3 options when you're comparing 2 things. All right? Your book used the letters A and B, but I just used X and 5. All right. And we have been talking about inequalities. So, you know, inequalities are just greater than, less than, greater than or equal to, less than or equal to, right? I hope you remember in class how we reviewed that greater than or less than is the open dot because it means it can include up into that point, but not including the point. So we just talked about 5. So if it were open dot at 5, it could go all the way up until that point, but it cannot include 5. But if it's or equal to, when we're graphing it, we put a dot and we actually shade it in because that means it can include the dot. And we say greater than or equal to, less than or equal to, so that we know it can also include it. One way I remember is because there's an extra marking here, you've got extra marking inside your dot. So I hope that is reasonable to you. And then our last part of lesson 39, your last lesson this week, is more advanced ratios. So let's jump into our practice. There are 4 of them, and we'll do a few of those together, all right? Just so that we're not too intimidated by our work this week. And I'm really proud of you guys. You're doing a great job just plugging away in our algebra book. Now let's take a look at our practice, letter A. It's the bottom of page 158. The team played 65 games. If the ratio of wins to losses was 3 to 2. There's our ratio, 3 to 2. And let's put a label, wins to losses, all right? Now, it also told us the team played a total of 65 games, all right? Now, where does that number come into play? Let's talk about it. How many games did the team win? Now, that's a really important thing because wins and losses, it didn't ask us how many did it lose. It asked how many did it win at the end. Well, one thing I want to point out to you is you always have to be filtering. You've got to be processing and logically thinking through what information did they give me and what do I need to solve for? How can I get there? Well, it did give me the ratio of wins to losses, but down here when it told me 65 games, that's our total. Well, if I'm looking for the total, I have to look up here at my ratios total. So 3 plus 2 equals 5. So if they won 3, they would win 3 wins out of 5 total, right? Well, that means they had to lose 2 and win 3. So if I have 65 total, how many of those were wins? So instead of a question mark, let's put W, right? So let's do our cross products. And remember, these subscripts are just to help me make sure I've got it in the right place. So it's 3 times 65 equals 5 times W. So 3 times 65 is 15. And then carry my 1. 6 times 3 is 18 plus 1 is 19 equals 5W. Divide both sides by 5, and I end up with my wins as 3. 5 times 3 is 15. 15, so that'll give me 4. So that is 39. So 39 wins would be the total number of wins I have for this season. So I can even write that. 39 equals wins for the season, right? Out of 65 games, I'm going to win 39. Well, that seems reasonable because that's more than half, and more than half they won, right? So that's very reasonable, very logical. Okay, now let's, letter B, I'm going to let you do at home. Letter C, draw a number line and graph the solution. X is not greater than or equal to 2. Now let's talk about that. If X is not greater than or equal to 2, what is X? There's only 3 options according to our trichotomy. If it's not greater than 2 and it's not equal to 2, X is less than 2, correct? So now how do I graph that? Well, here's 2, 3, and right before it would be 1. So it's an open dot. If it's not greater than 2, it has to be less, right? And if it's not equal to 2, it has to be less. All right, and then letter D, write both an inequality and a negative inequality that describes this graph. So let's look at letter D, all right? So it shows us a graph, and at -1, it is a closed dot, and it's going this way. So here's 0 and 1. So let's talk about that. So x is greater than or equal to -1 because it's moving to the right. I know it's 0 is more than owing, right? 1 is more than a -1. So x is greater than or equal to -1. How did I know that? Because it was shaded in. So I know it had to be or equal to. So what would be the negative of that? Well, it would say x is not less than -1. All right, so x is greater than or equal to -1. So according to the trichotomy principle, it cannot be this one since it is greater than or equal to that. So there's only 3 options it can be, right? So that was all of our practice except letter B, but we did A, C, and D. So I'm super proud of you guys, and I hope you have a great week. And I look forward to seeing you next week with some more fun Saxon Algebra. God bless you.